Now we go for the divergence. Divergence is nothing but div A, which is nothing but del dot A. Del dot A. A expression is given by this. A1 I vector, here it is A1 E1 cap. See, A1 E1 cap, A2 E2 cap, A3 E3 cap. So this can be expressed as individually, correct? So you remember this equation 3.16. It's a very important one. See here, we are going to evaluate, we are going to get the expression for del dot A. We have already got the expression for del phi. This is for the gradient. And next one is for the divergence. We are going to get the expression for del dot A. And this is for the Cartesian curvilinear coordinate system. Del dot A. Curvilinear coordinate system. So we have del dot A. So individually we can write this, where E1, E2, E3 all are unit vectors along the direction increasing with U1, U2, U3 respectively. Now we will go for the first one. Okay. So generally we can write del dot EI dot AI. I stands for 1, 2, 3. Is it okay? I stands for 1, 2, 3. So del dot EI dot AI, which is equal to, this is your vector identity. Vector identity, this can be written as AI del EI cap plus EI cap dot del A. So you have a vector identity, we have used a vector identity del dot EI dot AI dot del EI plus EI cap del A. First we will go with EI del A. See, our aim is to find out the expression for this, expression for this, expression for this. We are going to add all those things, we will get answer as del dot A, which is asked. What is this one? Divergence of a curvilinear coordinate system is asked. We are going to derive, we are going to get the expression for div A of curvilinear coordinate system. So now for that what we are going to do is, we are going to simplify this first expression as this one. We are going to get the answer for this, we are going to get the answer for this, so we can get the answer for the first one. If we know the first one, according to the permutation combinations, we can go for the second one and third one, easy. So this is the idea. Now first we will go for EI dot del A. EI, so EI, first one, so units of I will go for 1. So E1 dot. So del A1, we have already calculated divergence. We have already calculated gradient. We have already calculated gradient. So this del A is nothing but gradient. Del phi is nothing but gradient. Del dot A is nothing but divergence. So don't get confused. So we have now del AI. So for the first one we have del A1. So we'll have to use only this. Is it okay? I repeat. See here, we are going to get the expression for this. EI dot del AI. EI dot del AI. For the first one we are going to get. So I stands for now 1. So we have now 1. So E1 dot del A1. Already we have found out now del phi. We will have to use only this expression. This is gradient. So E1, see here E1 cap. So we have E1 cap divided by H1. Instead of phi, we will have to substitute A1. So dA1 by dA1. Similarly, plus this expression plus this. So this is for the second one. Okay. So we have, generally we can write, generally EI dot del AI, which is equal to 1 by H1 dAI by dUI. Generally we can write. Okay. So now multiply and divide by H2 and H3. See, I am going to multiply this, multiply by H2 and H3 and divide by H2 H3. So multiply by H2 H3 will give you H2 H3 here and here H2 H3 here. Is it okay? I am going to multiply this by H2 H3. Here also H2 H3. So we have 1 by H1 H2 H3 partial dA H2 H3 divided by dE1. The first term from equation 3.17. So 3.17 is given by this. So we have 3.17. We have got the expression for this. We will have to get the expression for this. Add these two will give you expression for this. Is it okay? Yeah, we have obtained the expression for this, which is nothing but this. Now we are going to have the expression for this. So we have now the expression for this. So first we will go for del dot E1. E1 can be represented by, can be E2 cross E3, correct? E1 can be written as E2 cross E3. E2 cross E3 is nothing but E1, which you have learned. So instead of E1 you can write E2 cross E3. Use the vector identity. So this will give you E3 dot del cross E2 minus E2 dot del cross E3. So this is your vector identity. Now let it be like this. Okay. Now consider, you just consider del cross E1 cap by H1. So leave it, let it be like this. So now just consider del cross E1 cap by H1. Use the vector identity. We have del 1 by H1 cross E1 plus 1 by H1 del cross E1. So this is another vector identity. Now I am going to interchange this one. A cross B equal to minus B cross A. I am going to interchange this. So when I am going to interchange, that will give you minus E1 cross del 1 by H1. This term let it be like. So we have this. Okay, we have. So left hand side of equation 3.23. So we have 3.23. Left hand side is nothing but del cross E1 by H1. Del cross E1 by H1. Del cross E1 by H1. What is this one? This is E1 by H1 is nothing but gradient U1. Gradient U1 is nothing but E1 by H1. So instead of E1 by H1 you can write grad U1. But del cross grad is always 0. Very important one more question. Del cross gradient will be always 0. We can most probably in vector calculus we have already proved this one. Del cross grad U1 always will be 0. So this is equal to 0. So left hand side equal to 0. We have only two terms here. So I can bring this term to this side. So I can bring this term to that side. Is it okay? So left hand side is 0. So I can bring this term to left hand side. That will give me this. Correct? So now del cross E1. Del cross E1 which is equal to cross multiply will give you H1 E1 cross del 1 by H1. Is it okay? See here del cross E1 which is equal to cross multiplying that H1, I can take H1, that will give me H1 E1 cross del 1 by H1. So H1 let it be like this. E1 is here. Del 1 by H1. Del 1 by H1 nothing but gradient of 1 by H1. So first we have learned gradient. See? Gradient. So we have now, instead of this, you have to write the expression for gradient. So this is for the gradient. That is E1 cap by H1 d by d1 1 by H1 plus for H2 and for H3. Now you have to differentiate H1 with respect to U1. So you will have to differentiate. So this becomes minus 1 by H1 squared. You will have to differentiate. For example, 1 by x will give you minus 1 by x squared. So similarly this one will give you minus 1 by H1 squared. Already one H1 is exists. So we have minus 1 by H1 cube. So this is after the differentiation. So we have now minus, see here, I have differentiated this with respect to U1. So that will give me minus 1 by H1 squared. Already one H1 is there. So we have minus 1 by H1 cube. Remaining thing and all let it be like this. Similarly for H2 and similarly for E2 cap and similarly for E3 cap. So now E1 cross E1. So E1 cross E1. So E1 cross E2. E1 cross E3. But we know already E1 cross E1 is 0. Okay. I cross I. E1 cross E1 is 0. What about E1 cross E2? Cyclic permutation, which is nothing but E3. E1 cross E3. Minus E2. So this is what last time I asked. So minus E2. One minus is there. So this becomes plus. So we have found out now del cross E1. So we have considered this. Can you remember? We have considered this. We have found out del cross E1. So we have found out del cross E1. Similarly, you can get the expression for del cross E2. Del cross E3. You can substitute all the three in equation 3.21. So we have del dot E1 which is given by this. So we have now del dot E1 which is equal to del dot E2 cross E3 which is equal to E3 which is equal to E3. So this is E3 and this is E2. It is not U3. This is E3. So we have E3, del dot E2. What is del cross E2? This one. See, del cross E2. What is del cross E3? So it is given by this. Del cross E3 is given by this. Okay. So we have now E3. This is E3 cap. So E3 cap dot del cross E2 is given by this minus this is E2 cap. So E2 cap del cross E3 is given by this. Now E3 dot E1. What is E3 dot E1? E3 dot E1 0. E3 dot E3 1. So we have 1. We will have to go only with this one. So we have 1 by H2 H1 dH2 divided by dE1. What of E2 dot E2? 1. So it is minus minus plus. So we have 1 by H3 H1 dH3 divided by dE1. What of the E2 dot E1? 0. So we have only these two terms. Now as usual I am going to multiply by H3 here and divide by H3. So that will give me 1 by H1 H2 H3 dH2 H3 divided by dE1. I am going to multiply this by H2. So that will give me partial dH2 H3 divided by H1 H2 H3. If both are the same, we can replace this by only one. So del dot E1 which is equal to, both are the same. See, both are the same. So that will give you del dot E1. Left hand side is del dot E1. So del dot E1 is given by this. Okay. Similarly, del dot E1. Okay. Substituting equation 3.34 here in 3.17. So we have 3.17. So 3.4. We are going to substitute 3.34 in 3.17. 3.17 is given by this. This is what we need. So del dot EI which is equal to, we have AI del dot E1. So del dot E1 is given by this. Okay, given by this. Plus EI del A is given by this. We need to calculate only this one. Okay, for any divergence we are going to calculate only this. So we have del dot, so we have del dot EI dot AI which is equal to AI del dot EI is given by this plus EI cap del cross del AI is given by this. Okay, so now E1 dot E1 dot E1 answer will be 1. So we have 1 by H1 dA1 by D1. This becomes 0. This becomes 0. So we have the same expression here. I am going to multiply and divide by H1 here. So H1 H2 H3 here it is H1 H3. See, it has become H1 H2 H3 here. Okay. Now I have brought A1 here inside. I have brought A1 here. So this becomes A1 H2 H3. Here I am going to multiply by H2 and H3. So this becomes A1 H2 H3 divided by H1 H3. See, both are the same. So we can write only once. So that will give me del dot E1 dot A1 which is equal to this expression. So we have obtained del dot E1 dot A1. Similarly, by cyclic permutation, del dot E2 A2. Wherever you find H1, you substitute H2. Wherever you find H2, substitute H3. Wherever you find H3, substitute H1. Simple one. So A1 becomes A1. H2 becomes H3. H3 becomes H1. So DE1 becomes DE2. See? A1 becomes A2. Similarly, del dot E3 dot A3 will give you this expression for this. Now you are going to add all those things. When you are going to add all those things, this is expression for del A, del dot A, divergence of A. So right hand side, you are going to add all those things. See, you are going to add all this. So this is the expression for your divergence. So now you are going to add all those things. You can pull common terms out, that will give you this. So this is the expression for your divergence of A in curvilinear coordinate system. So we have derived now. So this equation 3.41 represents div A in orthogonal curvilinear coordinate system. For any Cartesian coordinate system, as usual, h1 equal to h2 equal to h3 which is equal to 1, u1 equal to x, u2 equal to y, u3 equal to z. You substitute here, we'll have this becomes 1, this becomes 1, and this will be dA1 by du1, dA1 by, instead of u1, dx, so dA1 by dx, dA2 by dy, dA3 by dz. See, this is ordinary Cartesian coordinates. See, this is divergence of A for the ordinary Cartesian coordinates. Del A is given by this. This is for the curvilinear coordinate system. Divergence of A, and this is for divergence of A for the Cartesian coordinate system. Okay. So now we shall discuss for the curl. Curl is given as del cross A. Okay, del cross A is nothing but curl. So del cross A is nothing but E1 A1 plus E2 A2 plus E3 A3. So we can separately write. Okay, now del cross E1 A1 vector identity, we'll have to use this vector identity. Curl phi A is given by phi curl A minus A cross gradient phi. So now del cross E1 A1. So instead of phi A, you are going to write E1 A1. So that will give you A1 del cross E1 minus E1 cross del A1. You have to use this vector identity and get the expression for del cross E1 A1. Now we will have to get the expression for del cross E1 and E1 cross del A1, substitute here and get the expression. That's all. So as I said, del cross E1 A1. So del cross E1 can be written as, this is del cross E1. So equation 3.30. Okay, equation 3.30. We will have to use 3.30. So this is del cross E1. Already we have found out. Del cross E1 is nothing but 3.30. So we have now 3.30 and del A1 from 3.14. Del A is nothing but gradient of A1. Already we know this one. So we will have to substitute. Now that will give us, see, del cross E1. We know already we have found out. This is from equation 3.30. This is from equation 3.14. You substitute here in this expression. So that will give you this expression. Okay. Now I have written the same thing here. E1 cross E1. Answer is 0. E1 cross E2. Answer is E3. E1 cross E3. Answer is minus E2. See, that's why it is written as plus. Is it okay? E1 cross E1 is 0. E1 cross E2 equal to E3. E1 cross E3 minus E2. So that's why minus is there. Already minus is there. So that's why it's written as plus. Now you can pull E2. Same. See, E2 is here. Here also E2. So we have E2. Common. So we have A1 divided by H3 H1 dH1 by du3 and here dA1 by du3 and pull E3 cap out. So you can write this one and this one taking minus sign as common. Okay. Now you multiply, just bring this A1 here inside. So this will give you partial dA1 H1 divided by H3 H1 du3. Similarly, you multiply and divide by H1 here. So that will give you A1 H1 divided by H1 H3. See, you can pull H1 H3 out. And here A1 H1, you just multiply by H1 divided by H1. So that will give you this expression. So you can pull H3 H1 out. Here it is, you can pull H1 H2 out. So that's the reason. So that will give you del cross E1 A1. So both are the same. Here also both are the same. If both are the same, you can write only once. So we can write only once. This is for E2 and this is for E3. So by cyclic permutation, wherever you find H3, you have to substitute H1. Wherever you find H1, you have to substitute H2. So E2 becomes now E3 for del cross E2 A2. Similarly for del cross E3 A3. So that will give you this expression. Now you have to substitute all the three in equation 3.45. So this we have found out, this we have found out. So this is for equation 3.50, 3.51. This is for equation 3.52. We have substituted in 3.45 to get curl. So this is the expression for your curl. This can be written in a matrix form. Like for example, del cross A in Cartesian coordinate ijk. So usually we will do like this, correct? Del cross A can be written as ijk d by dx, d by dy, d by dz. Then if it is A, ax, ay, az, or a1, a2, a3, something like that. So we have now, instead of this, we have written in a matrix form. We will go for the first one. For example, we'll check. So this matrix simplification will give you this multiplied by this minus this multiplied by this. You remember this multiplied by this will give you dA3H3. See, dA3H3. Okay, divided by this du2 minus dA2H divided by du3. See, du3. So instead of this, we can write in a matrix form. So this is for the curvilinear coordinates, for the expression for the curl, Okay, so del cross A in curvilinear coordinate system is expressed as this. Now instead of h1, for h2, h3 for Cartesian coordinates, we'll have 1. So instead of h1, 1. Instead of e1 cap, you can write I. Instead of h2, you can write 1. Instead of e2 cap, you can write j. Instead of h3, you can write 1. e3 can be replaced by k. See, I, j, k. And this one becomes d by dx, d by dy, d by dz. And this becomes a1, a2, a3. This is ordinary Cartesian coordinate system, so it's equivalent. This is curvilinear coordinate system. This is ordinary Cartesian coordinate system. So this is the expression for your curl A in curvilinear coordinate system. So now we have come to the last one, Laplacian. So Laplacian from equation 3.41. Just take 3.41 here. 3.41, equation 3.41 is given by del dot A. What is del squared of A? Del dot del A. Del squared phi is nothing but del dot del phi. Similarly, we need to have only del squared A. Del dot A is known. Your del squared phi equal to del dot del phi. So similarly, del dot del A will give you del squared A, which is nothing but Laplacian. So we have del dot A expression is given by this. Okay, I have pulled h2, h3 out here. Here also I pulled out. Now del dot del phi, you just compare del dot del phi. Instead of A, you just substitute scalar function. So that will give you 1 by h1, h2, h3 del dot. So you have del dot del phi is given by this. Here del dot. Okay, what is del? D by du1, d by du2, d by du3. In ordinary Cartesian coordinate, del is nothing but du by dx, d by dy, du by dz. So here it is du by du1, du by du2, du by du3. So du by d1, du by d3. So this equation represents Laplacian in orthogonal curvilinear coordinates. This equation. Okay. Now instead of h1 equal to h2 equal to h3 equal to 1 for ordinary Cartesian coordinate system, then we have this becomes 1. What of this? This also will become 1. And here it is nothing but d phi by du1. d1 is nothing but x. So we have d phi by dx. Here it is d phi by dx. So that will give you d squared phi by dx squared. See, I repeat, ordinary Cartesian coordinates, this becomes 1. This becomes 1. This becomes d by dx. This becomes d phi by dx. So that will give you d squared phi by dx squared, which is a Cartesian coordinate system. See, ordinary Cartesian coordinate system. Del squared phi equal to Laplacian. Laplacian equation for the ordinary Cartesian coordinate system is given by this. So this is for the curvilinear system, and this is for the Cartesian coordinate system. Okay, and totally I have written in a slide. Okay, this is for the expression for your grad phi, and this is expression for your div A. This is the expression for your curl A, and this is expression for your Laplacian. All the 4 expressions for curvilinear coordinate systems. Okay, and for Cartesian coordinate system, this condition is being applied. And for cylindrical coordinates, which you are going to learn maybe in the next class, this one and this one. Okay, we will stop today. Thank you, students. We will see you in the next class.